So, thank you, Thomas. As I have been asked to say something about PDF within 7 minutes, which is a challenge, because PDF is such a huge subject. What can I say? For me, PDF, and this is the only image that I have in my head when I think about PDF, is that box. It is a box full of possibilities, capabilities, technologies that are included inside a standard. That standard, originally driven by Adobe, now is a published ISO standard called the ISO 32000-1:2008. It was the release date of the ISO 32000-1. Now, upcoming is the version 2, PDF 2.0, which will be the 32000-2. And there are a lot of new things coming up. I will tell something about that later on in another session. But one thing that's not pretty much visible to most of us is what does that mean? What is that? The specification itself, what's inside? I just wanted to extract some facts from the specification. So let's start with the lowest number that I have. It is 110 references to other standard documents. That means that you have 4 full A4 pages only containing references to other technologies that are incorporated or used in some way within PDF. We have 430 tables in the specification. You must, if you think about that, there should be someone that actually fills those tables. And there are a lot of such tables on those 917 A4 pages of the PDF specification itself. And with 970 pages, I can say there's a lot of text. I've counted the words. We have 416,000 words within that PDF standard. And if you think about, well, there's a factor. I have a personal opinion about that factor. For every written word, how many words are needed to get to that stage? I personally think that the factor is 1 to 100. So one written word has had 100 spoken words prior. So you can think how much stuff and how much has been discussed around that standard. And this gets even more intense in the last years because we, as it has been transitioned to the ISO, and there's an open community with a lot of people interacting with that the committee of the ISO 32000, and it can be sometimes relatively complicated. I myself had the chance to join the ISO meetings for 2 times, and it has been quite interesting because I thought, well, there are some guys chatting nicely with each other. What I've been actually facing was like kind of this. There are a lot of ideas, a lot of wishes, a lot of challenges, a lot of requirements going into the ISO 32000 and PDF 2.0 in particular now. And there's sometimes kind of a protest going on, which is challenging, entertaining, sometimes can be hard to take. Oh yeah, Leonhard, you agree? But it enriches that format as a whole, which is a very impressive chance for the future of what we can achieve with that format and what possibilities we will get into that format itself. So I've taken it a little bit faster. I'm already at the end. I could talk still 2 minutes and 50 seconds, but I'll stop here. Thank you very much.
Okay, thank you very much. I missed that Francois is a leader of our PDF Competency Center, so if you want to talk to bits and bytes these days, just do it. The next one is our member of the board, Carsten Heiermann. He will have 7 minutes, and I think he will make it for PDFA.
Yes, sure. Thank you very much. 7 minutes on PDFA. First and foremost, the PDFA standard is a mere 30 pages. Sorry, it's small, but those 30 pages tell you what to do with this big sum of possibilities of PDF in terms of making it archive ready, that PDF that comes out of that. So what features are risky and you don't want to have them in your archive? What features are okay in terms of documents that are stable and static, readable over a long, long time, and even in a future where we probably today can't predict what the technology we need to display these things on will look like. In order to do so and have static view on things that is as it is when you put it in your archive today in the far future, you need to take a certain set of precautions or measures today, and exactly that is PDFA. It describes what to do better or not. The archiving perspective, let's say, that we have here is a long one. We're not probably talking about the text documents that go away in 7 years or something. We are more talking about insurance documentations that have to be stored 20 years longer than the person who is insured lives. It could be long, gets longer over the time. It could be building documentations. They have to be stored in the typical usage period of a building. Could be long. And our librarians in the standardization say long is easy to define, it's forever. We don't do anything in preservation to throw it away at any time. So that's the scope, the time you're looking at when we talk about archiving and when we talk about PDFA. Therefore, the measures you need to take are, of course, you need to have a complete version independent, software independent, device independent specification and file, ending up with a file like that. All the content that you have in there can't be specific to anything. Stupid example, so when you have a computer-aided design file, CAD file today with an electricity plan of a building, these power plugs and everything else is a font. If you use that font and it's specific and it changes over the time because it changes in the system or in the application that provides it, it's a problem. If you use color schemas that are device dependent today and those devices change over the time, can't be interpreted or will be interpreted wrong, the document looks different. So you can't do any specifics in terms of software, devices, versions, whatever. Another aspect is the document needs to be self-contained, because in that long time you want to store a PDFA document for, you can't rely on the fact that a resource is there, whatever it is. Again, think about the font. The fonts in a PDF are normally referenced as to be in the system. And it's a pretty reliable thing doing it day to day to say this is encoded or displayed in Arial, right? It's there. Talking about 50 years, talking about 30 years, 20 years, 100 years, or even longer, is it or not? So when you need to render it, a specific resource, PDFA defines and demands to put it in the file. It has to be in there, and that's what we call self-contained. Self-documented is another thing that PDFA does from day one. It cares about metadata. It says, put it in context, describe what it is. XMP, we heard that word already this morning, is the metadata definition language, or the metadata, the way to store metadata into the PDFA files, and there's a whole lot of mandatory things around that. Transparent is just, it should be easy, it shouldn't be overly complex, easy to analyze, easy to structurally understand, so that there is a chance for a viewer that probably needs to be re-implemented on a holodeck in I don't know when to render that PDF document, that there's a chance to do it. So a very important aspect, and also a limiting factor for PDFA is to keep the appearance of a document static. That's why we started at some point to call it electronic paper. It almost feels like printing it out, making it static. It's fixed. It can be changed, but it can't look different from that point on if you do it right. But what it can't do is the same thing that can't be done when printing it to paper. You can't print a video to paper. So it's about static content. And in the version, or in the part 1 of the standard that came out first, this was even stronger enforced than it was in later parts of the standard. But it is still the case. It is for static, viewable content, and therefore the paradigm of calling it electronic paper kind of holds. Now, today we have 3 published and ready parts of the standard. It goes back to 2005, PDFA1. It was based on PDF 1.4. 1 plus 4 is 5, so it was the time when Acrobat Reader 5 was out there. Again, it was the time that we had to standardize archiving for the version of PDF that was just available at that point. Of course, PDF develops. Therefore, also something that should be very static, very for the long run, like a PDFA, like an archiving standard, has to evolve because our basis evolves. So we have to just explain how is it with these new features introduced in PDF 1.7 or ISO 32000? What are we going to, or what do we think about these specific features? Are they good for archiving? Should they be prohibited? Should they be limited or better explained in a way? Therefore, there are second and even later on a third part of PDFA coming out, and there will be more, although there's not a lot in the works right now, but we heard about ISO, about PDF 2.0, and for sure we have to sit down at some point and say, how do we treat that from an archiving perspective? So PDFA2, based on ISO 32000, PDFA3 added one more really difficult for some people feature, and that is you can now also store attachments, files of arbitrary formats like Excel spreadsheet into the PDFA documents as accompanying data in a way. Discussion around that is long. I'm not going to go into that here. There's extra sessions for that to figure that out. So all standard parts are published and used. No need to wait for anything there. Couple of use cases real quick. It is used today very widely for all the static content that is available out there. So it's of course for scanned documents. We saw that in the keynote. Scanned documents is a part of that. In mailroom solutions, exactly what we heard this morning. In records digitization, it uses additional technologies like compression, OCR and whatnot in these use cases. And those use cases are sometimes already pretty old compared to the age that the standard has reached at this point. More and more though, over the last years, all the content goes in there. Office documents, Born Digital content, we heard a lot about Born Digital. Yeah, good. Oh, that is it? The noise? I could, but I can finish this slide and I'm done. So basically, more and more different content is coming in there, and the latest trend in PDFA is probably email conversion, and you all know with an email you get everything, and you're in the middle of the discussion of the keynote of this morning talking about PDFA. More about that, I gotta go, sorry, but more about that, track 1 today at 2:15, there's more about PDFA. Thank you very much.
So the next one is Martin Bailey from the UK, so he's also a long-term PDF expert, and we are very happy that he just recently became the chair of our PDFVT Competency Center, and that's the reason why we talk about PDFVT. In 7 minutes, please.
And I'll try and do it quicker. I'm slightly hamstrung here because VT is being discussed before PDFX, and PDFVT builds on PDFX. So I'm going to leap in at what seems like halfway through a story. The PDFVT standard is designed to assist in variable data printing. VT stands for variable and transactional. Transactional printing is when you get credit card statements, phone bills, etc. It builds on top of PDFX in providing the reliability of the same kind of ensuring the same visual appearance as you need in PDFA is required in PDFX, is required in PDFVT, and it's done using very similar mechanisms to ensure that a file can be compliant with all 3 of those formats. Within PDFVT, we have 3 conformance levels. As you can see on the screen, the most common one right now is PDFVT1 because it's the simplest, everything in one single file. So if you're sending out a letter to 1 million recipients, you would send one file with 1 million times however many pages each recipient is going to get in that file. The adoption was a little bit slow. The standard was published in 2010. VT1 is starting to pick up quite nicely now. The second conformance level is PDF VT2, which is intended to support a chunking workflow. You can't do what some people would describe as real streaming with PDF, where you start creating a job from the database end and print the first pages before you finish creating the file, even with linearized. But what you can do is split into a series of chunks and put all the high-res images, etc., into a separate file and reference that. And PDF VT2 is designed to support that workflow. There are now some people using PDF VT2, and if there's anyone here who knows about any, please let me know, because I love to hear about more instances of this so we can make sure everyone works together. And finally, there's PDF VT2S, which is kind of a variant on VT2, hence the name. And I'm not sure of anyone actually using that yet. Again, if you know of anyone, let me know. What do I press on here? So around PDF VT, just like the other committees, there are a lot of people doing a lot of work in various interconnected ways. And there are actually at least three groups working on pushing VT forward. But it's a little bit incestuous, maybe is the right word, that the same people are on all of those committees. So you find yourself writing an email with one hat on and putting a different hat on and reading the mail and then having to do something about it. One of those groups is the committee inside ISO itself. All of these, or PDFX and PDF VT, are worked on in the Graphic Arts Technical Committee in ISO, TC130. That committee is preparing for the next version of PDF VT because PDF2 is coming along at the moment. As you can see, if I can get this, yay. The current PDF VT 2010, is based on PDFX4 and PDFX5, which was also published in 2010, and those are based on PDF 1.6. In a couple of years' time, we're expecting approval in spring of 2016, and maybe if ISO gets their act together, publication sometime the same year. We'll get PDF2. On top of that, the PDFX committee is talking about how they adopt that in what's currently called PDFX 2016. It may end up with a different name. And therefore, the PDF VT committee is talking about how they'll use the new version of PDFX, which is based on the new version of PDF. This stuff is structured to fit together, and sometimes that makes life interesting. In parallel, that same committee is developing ideas for a template-based variable data format, which is going to be related to but not part of PDF VT. I think I'm going to run out of time, so if you want to discuss that, grab me later. And then two other committees working on PDF VT. One is the PDF VT Competence Centre, part of the PDF Association. And the ISO committee have asked us to develop application notes for PDF VT because designing and releasing documents is a bit of a painful struggle through ISO at times, so having it owned by someone else is easier. And as part of that, the committee is working on filling a gap in PDF VT, which is in PDF, which is to allow people to include workflow control information within a PDF file, so that when you send a PDF file to a printer, you can say, this page is supposed to be the front of a duplex sheet, and this is supposed to be the back, but this one is only simplex, it's only printed on one page. A little bit about media selection, that kind of stuff. So that's going on in the PDF VT Competence Centre. And when the Competence Centre has decided what the requirements are and written out what we all need, we plan to pass over to the For Digital Printing Work Group, another organisation, who will encode that into a document as an extension to something they've already provided, which is a common metadata specification. So, like I say, a little bit of interaction between various committees, which makes things, feels as if it makes things a little complicated at times. In practice, what we try and do is choose the right committee who can own and distribute the documents in the right way to the right people. And that was my bit, and I've got 32 seconds left. Thank you.
Thank you. Next one, please. Okay, thank you, Martin. So there's also a very nice brochure. Uwe, please come already. There's also a very nice brochure, Do PDFVT Right, so you can get this over the days, obviously, and there are obviously sessions if you want to go more deeply into PDFVT. And now Uwe Wächter, who is also long-term with our PDF Association, will talk about PDFE for engineering. Uwe.
Okay, ladies and gentlemen, PDFE, the E stands for engineering. That specification is not that famous like the other ones, like X or A, but I think it's also very important. It's also one of the older standards. The first part of that standard is already from 2008, based on PDF 1.6. And as you may mention, very important feature of PDF for engineers is 3D content. That means you could use 3D content inside PDF. The first version of Acrobat could handle that 3D content was Acrobat 7, owned by the complete part for 3D PDF was here owned by Adobe. You could convert several CAD formats directly without the CAD application into 3D PDF. You could view that 3D content in the free Acrobat Reader, and you may integrate some 3D parts also in Microsoft Office applications. In this years, you have to buy two parts to convert 3D CAD applications into 3D PDF. You need Acrobat from Adobe and a plugin from the company Tetra 4D. If you want to produce 3D PDF on a server in a batch mode, there's a server owned by a ProStep company in Germany called 3D PDF Generator. As I already mentioned, the first part of that standard is already from 2008, based on PDF 1.6. We have now a newer part 2, but not ready, but in the state draft international standard. That part will be based on that PDF 2 standard. It's very important to know that the ISO committee included a lot of features, a lot of specification for long-term preservation into that part of PDFE. So from my point of view, it's very similar to PDF A2. I'm not really sure, I'm not 100% sure if it covers the full range of PDFA, but I think it's maybe important to think about to have that long-term archiving features in mind, and also as a possibility to store 3D parts in PDF. We have 3 levels of PDF E2. With S level means secure, that means you have the possibility to encrypt your files. Especially 3D PDF files have a lot of knowledge content in themselves, knowledge of the companies, and so a lot of companies would like to encrypt these files. So there's a special level of that standard. You also may include attachment files inside PDFE, and PDF E2R means you are limited on attachments that are equal to PDFA or PDFE again. The important feature of PDFE are the 3D content. You have two different file formats, Universal 3D or the PRC format. The Universal 3D is the older one. It's an ECMA standard. It's not an exact geometry. It's only tessellated, but maybe also animated. It was the first 3D feature inside PDFA. It was already included in PDFE1. From my point of view, the better format is PRC, Product Representation Compact. It's also an ISO standard since the last year. You may have exact geometry. It's also possible to extract again that geometry content out of 3D PDF. You may navigate in a part structure inside that PDF file, and you have product manufacturing information inside that file. This PRC format shows a very good compression. It becomes part of that standard with the second part of PDFE. Just to show an example how 3D PDF could look like, I'm not sure if this is really a PDFE file, but it's a typical 3D PDF file. In the upper left corner, you could see the 3D content. There's one part marked with some kind of red color. This part has a focus, and the lower left corner. The upper left corner, you see some checklist. You may push on these buttons and these numbers, these red numbers, and could realize what happens in that 3D part. And you have on the upper right corner some detailed information about how to handle that part. You could imagine you could fill this information out of your product lifecycle management, produce such files out of your product lifecycle management, and have this information offline, for instance. If you encounter some problems with these parts, you make some notices or make some checkboxes on the lower right side. And if you are ready with handling these parts, you could transport that content, these notices into your product lifecycle management again. So, thank you very much. Einen weiter noch.
Jetzt müssen wir die Präsentation haben.
I don't use preview.
You will know.
I will now. Okay. Why not? That one. Okay.
Okay, it's Leonhard Rosenthol from Adobe with 7 minutes.
You want to tell me how to do full screen on this? Oh, that thing on the right. There we go.
Okay.
All right. Nobody tell my company I'm not using Reader to do this presentation. Okay. So I'm going to talk about PDFX, and actually you've heard a lot about it from a number of people, so I'm going to skip over some of the things that are on the slides because you've already heard them rather than repeating them. But going back, the design goals for PDFX, as you sort of heard already, were about the ability for the pre-press industry, the print and production industry, to have their files exchanged from the people producing them, the graphic artists, all the way to the actual print, and ensure that what came out on the printer is what the actual person who designed it saw when they did the authoring. And that process was what's called blind exchange. Usually you didn't talk to them. You sent an email or FTP or whatever the process was, and you just expected the right thing to happen. And so PDFX was the standard that made that possible. And it did that really by doing a couple of things. One was to make sure that everything that was necessary was embedded. So obviously fonts needed to be embedded, colors needed to be strictly specified, information about what's called trapping had to be included. And then anything that PDF supported, and you've heard some of the many things so far and will throughout the next 2 days, that were not used in printing, like 3D and video and the like, weren't allowed. And so those were taken out of the standard. And you put all that together, and you got PDFX. And there were a lot of groups that were involved in this process, and it goes all the way back. In fact, the process started long before PDF actually. It started in 1990 with the graphic arts industry. The first thing they actually did was to figure out a way to solve this problem using TIFF. As you heard earlier today, TIFF's been around a long time as an imaging format, and so the print industry started with TIFF as their solution. Once PDF came onto the scene, they worked very closely with Adobe to come up with this first subset standard, PDFX, in 1999. And as you'll see, there are a lot of different flavors. So we've had the opportunity now to come up with 5 different variants of PDFX. So it's been around the longest. It's had the opportunity to create the most variants. So in a nutshell, since we don't actually have a book yet for PDFX, I'll give you the nutshell version. So it is a subset originally of either PDF 1.3 or 1.4, and then more recently 1.6. We talked about no security, no annotations, because those cover over, as we heard our keynote speaker talk about, cover over the content that was important. And again, as I mentioned, we want to include things that were necessary. An output intent. What's the exact colors that I want to output? What's it going to look like? Is this file already trapped or not? What's the bleed? What's the trim? How exactly on the page does this stuff fit together? Talked about the fonts being embedded. And then the other thing that PDFX started is a concept that has also gone into all of the subset standards, which you don't hear as much about, and that's the idea of a term called a conforming viewer, and the requirement that your viewer actually has to do certain things different from how it would react from a regular PDF. So you can't just take a PDFX file or PDFA or any of the other standards you've heard about and put it in an arbitrary PDF viewer and expect the right thing to happen. That's actually not how it works. You need a viewer that itself is aware of the extra requirements of the standard. And this is true for X and A and the other standards you've heard about. So it's something else to keep in mind, and it's part of the standard we don't normally talk about, but you need the reader to go with it. So talk about X1A was the first version of PDFX, followed by PDFX3, which went from basic colors to color managed colors. And then in 2008 came our new versions, and these are the versions that the industry is moving towards very quickly, not as quickly as we would like, but certainly more quickly than we expected, for 2 main reasons. One is the adoption of the PDF transparency model. Once that came on board, and more importantly, once the industry understood what it meant to render and process and work with transparency, it became important for printers to be able to print that reliably. And that's now available with PDFX4. And the other is optional content. I'll talk a little bit about that now, and actually much later in my presentation this afternoon. Improved image compression was another big thing that came about from X4. XMP you've heard about already. That also became important to the print industry. And then we learned a lot from PDFA, and we incorporated those as well. Let me just talk a little bit about those 2 highlighted items. So one of the most important reasons for PDFX4 was to finally solve the transparency flattening problem. I don't know if it comes, it does come across pretty well on the projector. You can see on the left-hand side what happens if you flatten a very complex set of transparency. See those little white lines in there. And this happens, these seams, because when you flatten transparency, it breaks it all up. So it avoids that problem. And what we want is we don't want those white lines. So we don't have to flatten transparency. We don't want it. We want this file to go natively through the process. And that was one of the biggest wins in PDFX4 and X5. The other one came for an industry that had previously been ignored, which was the packaging industry. So this is actually one of the biggest growth areas in printing, because it's kind of hard not to print a package. So packaging industry continues to grow, and their needs continue to grow and push a lot of the requirements in this industry. So we see that for optional content. There's also a variant called PDFX4P. In fact, one of the people in this room is the responsible party for that, and he shall go remain nameless because he actually didn't adopt it after he pushed it. But needless to say, we have it, and we actually have utilized it in a couple of cases. But more importantly, as Martin pointed out, was the need for external graphics, and that's for X5, and it is a key part of the PDF-VT standard you just heard about. I also want to put a word in for another organization that works closely with the PDF Association called the Ghent Work Group, and they build upon PDFX and what they call PDFX Plus, which is to take the standard and incorporate workflow-specific additions on top of PDFX for specific industries or specific types of printing. So if this is an industry that's important to you, I recommend you can talk to a number of us here in this room that also work with the Ghent Work Group. So it's a very good idea to build upon the standard. And I'd like to see that in PDFA and other places as well. Great, perfect. And I'll just wrap up real quickly. As Martin just mentioned, PDFX has just restarted trying to figure out what's next and how do we align with PDF 2.0. And if anyone has any questions on that, I'm happy to talk to you outside. So thank you very much.
Thank you very much, Leonhard. Last but not least, PDFUA by Olaf. You find your presentation.
Yeah, so last but not least, I'll briefly introduce you to PDFUA, and just trying to describe to those of you who don't know about accessibility in TAG PDF already, let me point out that PDF, invented in 1993, can really be considered the gold standard for visual presentation. So it really excels at presenting content in a visual fashion. Static content, most of the time, two-dimensional, and it has become the format of choice in this context, especially if you want to exchange that information. It's about page-based content, and I think everybody of us, even our parents, who may already be relatively old by now, may have PDF files on their tablets and computers. That cannot be said of many formats. In 2001, something else came along. At that time, still designed and published by Adobe, who at that time still was in control of the PDF format, which was handed over to ISO in 2008. And they introduced TAG PDF. And the value proposition on top of the visual presentation was add semantics. So be able to explain what that content actually is that you have in your file. And so you should be able, using TAG PDF, to say whether your piece of text is a paragraph or a heading maybe. Or whether the content you're looking at is a part of a table cell, which you would not be able to determine on a programmatic level by just looking at the encoding of a piece of text somewhere on the page. Or whether an item is a numbered list and so forth. And then beyond that, beyond just being able to classify or categorize certain parts of the content, it would be nice, and is supported by TAG PDF, to express what the overall content structure is. Where's the start, where's the end? Is there any hierarchical structure in the file? It can be expressed using TAG PDF. Or for content that doesn't exist, or text content, there's now a mechanism in TAG PDF to express that content based on text as in form of alternate text. And there's a number of reasons for this having been introduced, a number of use cases, and it's not just accessibility to help people access the content who can't easily look at the content on screen. There are other use cases like automatic content extraction, quite relevant for search engines and indexing and so forth, if you want to do a better job than just looking at sequences of characters. There's also the use case of repurposing. Just look at your smartphone. I find it difficult to read A4 pages on a smartphone. So you have the option, if you have a decently tagged PDF file, to extract the content and repurpose it into a reflowable format. And some tools are supporting that. And last but not least, what I mentioned already, you can use tag PDF to make PDF files accessible to people who have difficulty to just look at content on the screen or on the printout. So it was an excellent step forward in 2001. A lot of applications started actually using tag PDF and so forth, and for all kinds of purposes, but there remained a problem. Despite all the powerful functionality, there were no clear rules how to put it to work. So certain people created tag PDF files in one way, and then consuming applications expected content to show up in a different way, and there was a lot of lack of interoperability. And that's the main thing that PDFUA fixed. So it came out in July 2012. You can read the name of the full name of the standard on the slide. And the goal of PDFUA was to turn tag PDF into something that's universally accessible in all directions. It clearly has accessibility in mind, accessibility for people with disabilities, but it's useful in many other directions. And it aims to combine the semantic representation excellence with the visual presentation excellence you can only find on this quality level in PDF. It establishes clear rules, sometimes pretty demanding rules, how to create PDFUA files, well-tagged PDF files, and how to process them. So it's about the conforming viewer again that Leonhard was alluding to. So it's not sufficient to create a nice file, you have to have nice tools to really take advantage of these nice files. The mission is to achieve a level of interoperability that has not been achieved so far, and to do it in a fashion that's realistic. I mean, you can always dream up something that's super cool, and if it's too challenging to implement it, it may never happen. So it was important to come up with a realistic approach so that implementations can be done in a really cost-effective manner. It's already 2 years, almost 2 years since PDFUA came out. It's a relatively short time frame for ISO standards. Usually it takes years before you see good implementations and so on, but already now we see a wide range of tools that support PDFUA in one way or another. Maybe not always completely yet, but a lot of progress has been made. And there are tools to help you create PDFUA files, tools to check PDFUA files, and tools to do something useful with PDFUA files. And there will be a couple of sessions during these 2 days that explain how these work and how you can take advantage of them. It's still a complex topic. It's a new topic for many developers and also for users. So that's why the PDF Association and other organizations like AIM in the US have working groups going on, working on these topics, coming up with material to explain PDFUA so that you can understand it more easily. We have done PDFUA seminars. I think by now it's about 20 UA seminars we had, at least already in Europe. We do have a PDFUA in a nutshell booklet in German and English, in paper form, in PDF form, and ebook form. We have a Matterhorn protocol developed by the PDFUA Competence Center in the PDF Association. It's really targeting mostly developers to help them turn their application into a PDFUA-enabled application. And that's what I wanted to share with you as an introduction to PDFUA. Thank you.